Okay, I'm going to speak in English because my master thesis is also written in English, so that's easier for me. So the name of my research is Comparison of Energy Performance Calculation and Energy Indicators of Reference Building for Bosnia and Herzegovina and France. The reason why I chose France is because I have studied there abroad, and I have done my research for the French part in a city level. So, Bosnia and Herzegovina as a country has high energy intensity, 4 times higher than the countries of the European Union. Also, it has 10 times lower GDP comparing the European Union countries, and it spends 3 times less primary energy per inhabitant. All of those are the matters that we should improve, and comparing to European Union, where the statistical data regarding the building energy consumptions and regular inspection of the heating and air conditioning system is done, which is not the case in Bosnia, but it will be soon in use. And European Union is increasing the numbers of nearly zero energy buildings, which is not the case in Bosnia. So, for my research, I took one building for a typical building from the typology of Bosnia and Herzegovina. It is a single-family house from a north region with a number of floors 2, as you can see here. The heated space volume is 149.23, and the net surface of the heated space is 67.83 meters cubed, and time of use is from 8 a.m. until 10 p.m. But this is not the real values of using the heated energy. It is only for the type of my research. As we can see from the thermal photo, the values of thermal transmittance for the building envelope are much higher than the maximum allowed one for the both countries, Bosnia and Herzegovina and France. And because of that, there should be done many measures to decrease the numbers of the transmittance envelopes for the both countries. For example, if we take in consideration the external walls, the value of the thermal transmittance is 1.86. while the maximum allowed one is 0.35 for the Bosnia and 0.24 for the France. And as I mentioned, on the thermal photo, we can see many thermal bridges, which are bad for the insulation and bad for the maximum allowed heated energy of the building. So, in order to classify the energy class of the house or the building, we have to calculate the relative specific heated energy for heating, and it represents the ratio between the specific heated, annual heating for reference area and the maximum allowed energy for heating. And the maximum allowed heated energy for heating can be calculated from the building shape factor that we can see on this table. So after we have done the energy performance of the indicators for Bosnia and Herzegovina, we can see that the total delivered energy, which is here, represents the sum of the energies for heating, for domestic hot water, and for the auxiliary energy. And the specific value of energy for heating, which is 303.1, is used to calculate the energy class of the house, and in my case is the class E, which represents the really energy inefficient class, and it should be improved. For the front part of the calculation, they use not only the specific heated energy to calculate the energy class, but they also use cooling, domestic hot water system, lighting, and auxiliary energy for thermotechnical systems, and they use the values of BBO, which represents the bioclimatic needs, and CAP, which represents the specific primary energy for the building we are using. And after the calculating those parameters, we can see that the building represents the energy class G, which is the most energy inefficient energy class. And I also want to mention that for the France part, the energy classes that are energy efficient are A and B, while all others are energy inefficient. And for the Bosnia, which I forgot to mention before, the energy efficient classes are A plus, A, and B. And here are the calculated energy performance indicators for the France. And for them, total delivered energy is calculated for heating, domestic hot water system, auxiliary, and auxiliary systems, they bring in them all of the other, for example, ventilation and others, then cooling, lighting, and the specific value that is calculated for the energy class is 562.5. This is the number here. So after we have seen that the energy classes for both countries are low, we have to do some measures to improve the energy classes of the buildings. And the first measure I took was architectural measures for energy performance improvement. We have changed the insulation of the buildings. I have changed the external insulation of the external walls and also the insulation of the ceiling that separates the heated area of the building with the unheated ceiling and the roof. And also the windows are changed because the windows that have been on the baseline were just the wood windows, and now the PVC windows are in use. And after we have done the architectural measures, we can see that the thermal resistance of the building envelope are much lower, and now they correspond to the maximum allowed values for both countries, Bosnia and France. For example, external wall, the values of the thermal transmittance is now 0.22, and it is lower than the maximum allowed ones. Also, I want to say that we didn't take in consideration the ground floors because the energy efficiency of changing the floors and also the payback period is much lower comparing to the changing of the windows or changing the insulation of the external walls. So, after taking the architectural measures, we can see on both tables that the energy need for both countries is now lower. And for example, for energy need for heating is now only 83.3, while the one on the baseline was 303.1. And because of that, and because of using the architectural measurements, now the energy class of the building is B, which is energy efficient house. For the France, after calculating the new values, after using the architectural measures, the energy class is E, which is better than the one on the baseline, but still it is far away from the maximum allowed one, which should be A or B. So after using the architectural measures, we have changed the thermotechnical system of the building, which is now, as we can see here, the ground source heat pump, which is used for heating and domestic hot water in the winter period and for the cooling in the summer period. After using the changing thermotechnical system, the energy class of the building is still B. Why? Because for Bosnia and Herzegovina, for calculation of the energy class, it is only use energy for heating, and that should be changed. And for the France, as we can see, after changing thermotechnical system, the energy class calculated is C. It is visible that it has changed, but still it is not A or B. But after, if we add the solar panels, which would be combined with the heat pump, and also after changing the ventilation, which won't be only the natural air, but it will be the mechanical ventilation, it is noticeable that the energy class of the house will be probably B or A. And energy cost saving analysis of the improvement measures. After we have done both architectural and thermotechnical measures, we can now calculate the investment cost and simple payback period of the investments that we have done on the buildings. So we can see that the investment cost on architectural measures is 320 euros, and the simple payback period is 6.1 years. And after including the installing of heat pump, the total technical measurements, including the architectural measurements, are now 16,037 euros, and the simple payback period is 10.3 years, which is great. So if we see that we have been using the small, simple, single-family house, the simple payback period is really great, and this can be really useful to use in more buildings, which is not the case in Bosnia. So the conclusion, we can see that the energy performance calculation methodology for residential buildings in Federation of Bosnia and Herzegovina accounts energy need for heating, domestic hot water, and auxiliary energy of element of heating and DHV systems. Therefore, when architectural improvement measures for improvement of thermal performance of building envelope are applied, energy class of building will improve. Technical measures which result in a more efficient energy conversion or decrease of an energy consumption of auxiliary system does not contribute in any performance indicator. Calculation methodology in France account the total primary energy for following system: heating, cooling, DHV, and lighting, as well as auxiliary energy of all systems. When delivered, or even better, primary energy is used as an energy indicator. They encounter efficiency of the thermotechnical systems, but also primary energy conversion factor and its environmental impact. These result in use of more efficient thermotechnical systems and fuels or energy carrier with smaller primary energy conversion factor, and also use of renewable energy sources such as solar panels to decrease the building energy indicator. Thank you for your attention.